Let's solve one more numerical. Now, in the question number 1, he is asking find the number of hydrogen atoms in 4 gram of methane. So, the solution will be now we have to find out the number of moles. For the number of moles, we need given weight of methane, that is equal to, it's given 4 grams, and the molar mass of methane is equal to 16 grams. Now, we have given weight, we have molar mass. So, what is the formula of number of moles? That is given weight upon molar mass. So, number of moles of methane is equal to 4 by 16, and that is equal to 0.25 mole. Now, what we have to do, we have to relate the number of hydrogen atoms with the number of moles. So, for one mole of methane, we will have 4 into Na, that is Avogadro number, hydrogen atoms, right? But we don't have 1 mole, we have 0.25 moles. So, for 0.25 moles of methane, it will be Avogadro number of hydrogen atom. So guys, that's how we will find the number of moles and the number of hydrogen atom in these type of questions. Now there is an alternate method also, and that is very simple, and if you are having the problem to solve these type of question by finding the number of moles, so you can adopt this method also. Let's see how we will solve the questions in this method. That is alternate method. Now in this alternate method, we will always solve for 1 mole. Now let's check what is given in the question. 4 gram of methane is given, and he is asking the number of hydrogen atoms. So what we have to do, we have to find out the relation between the mass of methane and the number of hydrogen atoms, and that relation is for 1 mole methane, we all know that molar mass of methane is 16. So 16 gram of methane will have right. Now weight given to us is 4 gram. So 4 gram it will have Avogadro number of hydrogen atoms. So we can solve the questions by this method also. Let's move on to next question. Now in this question he is asking, find the number of atom of each element in 10 gram of calcium carbonate. Now we will solve this question with alternate method. We will not find out the number of moles. Let's do it by alternate method. Now the solution will be if we have 100 gram of calcium carbonate. Why I am doing that? Because 1 mole of calcium carbonate is 100 grams, right? So if we have calcium carbonate, then it is 1 mole. The elements present are calcium, carbon and oxygen, and they will be one mole. This is also 1 mole, and in 1 mole of calcium carbonate you can clearly see that there are 3 moles of oxygen. Therefore oxygen atoms will be 3 into Na. Do we have 100 gram of calcium carbonate? No, we have 10 gram of calcium carbonate. So in 100 gram of calcium carbonate we have these numbers of atoms of these elements. Therefore for 10 gram of calcium carbonate, again calcium, carbon and oxygen we will write, and the number will be equal to 0.1 into Na. (0.1 into Na) again, and 0.3 into Na. So guys, this is the final answer of this question. Let's move on to the next question. Now in this question he is asking, if the weight of hydrogen is 30 gram in ammonia, we have a sample of ammonia and we have to find out the weight of that sample in which 30 gram of hydrogen is given. So again we will apply unitary method, again that alternate method. Without finding out the number of moles, we will find the answer. Let's solve it. Now, for 1 mole of ammonia, 1 ammonia. Now it is 17 gram, right? Now, in 17 gram, nitrogen is 14 gram and hydrogen is 3 grams. Now what we have to do? 3 grams of now if we have 3 grams of hydrogen, we will have 17 gram of ammonia, right? But we have 30 gram. So if we have if we have 30 gram of hydrogen, the weight of the ammonia will be equal to 17 multiplied by 30 divided by 3, and that is equal to 170 gram, right? Let's solve some more questions. Now in this question he is asking, if an enzyme molecule contains 0.5% of sulfur in it, then what will be the minimum molecular mass? Now this word minimum we have to consider, and if minimum is there, the minimum number of sulfur atoms will be present in that particular molecule or that particular enzyme, and the minimum number is 1. We all know that the atomic mass of sulfur is 32 AMU. Let's proceed the solution. So the solution will be now 0.5% of that enzyme or of is equal to 32 U or AMU. If we take 1% of the enzyme that is equal to 64 AMU, and 100% will give us the molecular mass of that particular enzyme. So enzyme that is equal to so this is the final answer of this question. Let's solve another question.